Notes 2.5, the power rule. Okay, so now I'm going to introduce how to actually find the derivative. So after these notes and so on, because once I show you all the rules, you will no longer have to use the definition of a derivative. So we know how to find the derivative of a function based off of the definition of a derivative. Okay, so I'm going to show you how I know that the derivative of x squared is 2x. Okay, so first, looking back to what we already know. So we know that the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, that's the same as saying x plus h squared minus x squared. So this is x squared plus 2xh plus h squared minus x squared. The x squareds cancel out. Everything left over is divided by h. I cancel out an h from each of these, and I am left with 2x plus h. But as h approaches 0, this is just 2x. So that's how you found the derivative before. Now let's talk about the power rule. So the power rule says that if we have a function x to the n power, so this could be any exponent, then the derivative is simply n times x to the n minus 1. Okay? I would memorize this. Okay? If you have a function x to the n, the derivative of that is n times x to the n minus 1. So what does that mean? Okay, so I'm going to look at the example f of x is equal to x to the third power. So I'm just going to write it a little bigger off to the side. Okay. We know that the exponent 3 is n. So I'm going to bring this to the front and subtract 1. So when I do that, I get 3x to the 3 minus 1, which is 3x squared, which means the derivative of x cubed is 3x squared. And you would do the same to each of them. Bring down the 4 and subtract 1. So this is 4x cubed. Bring down the 5 and subtract 1. 5x to the 4th. Okay, it even is true for this one that we did the definition for. Bring down 2, subtract 1. That's 2x to the first power, or in other words, just 2x. Okay, so let's look at some easy examples. Okay, so continuing what we were just doing. We know that y prime is going to be equal to 37x minus 37 minus 1, so 36. Okay, we bring down the n value, we bring down the exponent, and then subtract 1. Okay, so this would be y prime is equal to 9x to the 8th power. Bring down the 9 and subtract 1. Okay, now let's look at some not so easy examples. Okay, and the reason why we say they're not so easy is because you have to remember your properties of exponents and recall that we can rewrite these in terms of an exponent, so x to the n power. So the function y is equal to 1 over x is the same as saying y is equal to x to the negative 1 power. So if we were to take the derivative of this, we would bring down the negative 1, so this would be y prime is equal to negative 1x, and then minus 1 minus 1, so negative 1 minus 1. Okay, so this is negative x minus 2. Well, then we have to rewrite it. Okay, well, if we were to rewrite this, we know that x to the negative 1 power is 1 over x. So negative x to the negative 2 power is just going to be negative 1 over x squared. So again, we are thinking back to our properties of exponents in order to do these. Okay, so this one, this is the same as saying y is equal to x to the negative 4 power. y prime would be negative 4x to the negative 5 power, because I'm subtracting 1, which is the same as saying y prime is equal to negative 4. Okay, so before we didn't have a number in the front. That's why we didn't write the number at the top. Over x to the 5th power. Example 5. Well, we know y is equal to the square root of x is the same as saying y is equal to x to the 1/2 power. Okay, using the power rule, y prime is equal to 1/2 x, and then 1/2 minus 1, so that's negative 1/2. Okay. Well, negative 1/2 power just tells us that the square root is now in the denominator. So this is the same as saying 1 over 2 square roots of x. Okay. Y is equal to the 7th root of x cubed. We know that this is the same as writing y is equal to x to the 3/7 power. So the derivative of this would be 3/7 x to the whatever 3/7 minus 1 is, so negative 4/7. So think of it like this. We did 3/7 minus 7/7, which is negative 4/7. Okay. Negative 4/7 is going to be written first in the denominator because it's negative. Okay, so first we would have y prime is equal to 3 over 7x to the 4/7. Okay, well, 4/7 is the same as saying the 7th root of x to the 4th. So this is 3 over 7, 7th root of x to the 4. Okay, so let's look at some more examples. Okay, so these ones are a little trickier. Okay, the reason for that is you need to simplify first before you take the derivative. And for all of these, we are going to use the power rule to find the derivative. Okay, so once we find the derivative, it wants us to find f prime of 7. So first, we know that f of x equal to x over the square root of x is the same as saying x over x to the 1/2 power. Okay, if we were to bring that to the top, this would be x times x to the negative 1/2 power. Okay, and remember when we multiply the same base, we add the exponent. So this is the same as saying x to the 1/2 power, which means f prime of x is equal to 1/2 x to the negative 1/2 power, which is the same as saying 1 over 2 square roots of x. Then we can plug in 7, so f prime of 7 is equal to 1 over 2 square roots of 7. And I would leave it like this. Yes. Okay, so the reason why I'm leaving it like this is because I can't simplify the square root of 7 any further, and I do not want to convert this to a decimal. Okay, number 8. So f of x equal to the cube root of x times x cubed. We know that this is the same as saying x to the 1/3 power times x cubed. Okay, which means if we are multiplying with the same base, we would add the exponent. So this is the same as x to the 1/3 plus 3, which is equal to x to the 10/3. So I have to make a common denominator. I can say this is the same as saying 9 over 3. That's how I got 10/3. Then I take the derivative. So this is going to be 10/3 x to the 10/3 minus 1. Okay, 10/3 minus 1 would be 7/3. Okay. I would rewrite this so I have the 7/3 in a proper notation. So I know that 7/3 x to the 7/3 is the same thing as saying the cube root of x to the 7th power. So this would be 10 the cube root of x to the 7th power over 3. Then I'm going to plug in f prime of 8. So I have 10 cube root of 8 to the 7th power over 3. Okay. 8 to the 7th power, and then taking the cube root of that, you could just plug that into the calculator. You get 128. So this is 10 times 128 over 3, which is equal to 1,280 divided by 3. And again, you do not need to simplify this. Okay. Now let's look at the last example. It says parallel tangent lines. So it says let f of x is equal to x to the 4th and g of x is equal to x to the 3rd. At what values of x do the graphs f and g have parallel tangent lines? So what does that mean? So parallel lines imply that they have the same slope. So what do we need to find? Well, we need to see if f prime of x is equal to g prime of x. Okay. Well, we first need to find each of those. So f prime of x would be 4x cubed, because you bring down the 4, reduce the exponent by 1, and g prime of x would be 3x squared. Okay, then we'd have to set them equal to each other. Well, 4x cubed equal to 3x squared. We would first have to get all the x's to one side. So this is 4x cubed minus 3x squared equals 0. I could then take out an x squared, and so I'm left with 4x minus 3 equals 0. I set each of them equal to 0, so x squared equals 0 implies that x is equal to 0, so that's one value. And 4x minus 3 equals 0 implies that x is equal to 3/4. So those would be my two values for which the graphs of f and g have parallel tangent lines.